Multiprocessing, how to use Pool.map on a function defined in a class. When I run something like, it works fine. However, putting this as a function of a class gives me the following error. I've seen a post from Alex Martelli dealing with the same kind of problem, but it wasn't explicit enough.
I could not use the code posted so far because code using multiprocessing.pool do not work with lambda expressions, and code not using multiprocessing.pool spawn as many processes as there are work items. I adapted the code st. It spawns a predefined amount of workers and only iterates through the input list if there exists an idle worker. I also enabled the daemon mode for the workers. st Ctrl+C works as expected.
Multiprocessing and pickling is broken and limited unless you jump outside the standard library. If you use a fork of multiprocessing called pathos.multiprocessing, you can directly use classes and class methods in multiprocessing's map functions. This is because DIL is used instead of pickle or pickle, and DIL can serialize almost anything in Python. Pathos.multiprocessing also provides an asynchronous map function, and it can map functions with multiple arguments, e.g. map, math.pow, 1, 2, 3, 4, 5, 6. See discussions. What can multiprocessing and DIL do together? And this URL. It even handles the code you wrote initially, without modification, and from the interpreter. Why do anything else that's more fragile and specific to a single case? Get the code here, this URL, and just to show off a little more of what it can do.
I also was annoyed by restrictions on what sort of functions Pool.map could accept. I wrote the following to circumvent this. It appears to work, even for recursive use of Pool.map.
There is currently no solution to your problem. As far as I know, the function that you give to map must be accessible through an import of your module. This is why Robert's code works. The function f can be obtained by importing the following code. I actually added a main section because this follows the recommendations for the Windows platform. Make sure that the main module can be safely imported by a new Python interpreter without causing unintended side effects. I also added an uppercase letter in front of calculate, so as to follow PEP 8. Smiley face. The solution by rule is correct but has a bug. If the child sends back a large amount of data, it can fill the pipe's buffer, blocking on the child's pipe.send, while the parent is waiting for the child to exit on pipe.join. The solution is to read the child's data before joining the child. Furthermore, the child should close the parent's end of the pipe to prevent a deadlock. The code below fixes that. Also be aware that this Pool.map creates one process per element in X. A more advanced solution is to use multiprocessing.cpu_count to divide X into a number of chunks, and then merge the results before returning. I leave that as an exercise to the reader so as not to spoil the conciseness of the nice answer by rule. Winky face.
If you want to support the channel, please consider liking and subscribing.